Welcome to the channel of Hansen Technology. Today we are talking about VMC, aka Virtual Mechatronic Commissioning. The industry has already done a lot with virtual commissioning, but in many projects it is still used late in the process. The equipment is almost built, a digital model is created for demonstration or handover, and the result looks impressive, but it has limited impact on the design process itself. VMC intends to change the timing. It brings virtual commissioning back into the design stage. While the mechanical design is still being refined and the PLC program is still being written, real control logic can already drive a virtual machine model. Interference, cycle time, signal, and safety logic issues can be resolved while the design is still open. This is not a decoration at project closeout, it is engineering validation before manufacturing. In traditional equipment projects, mechanical design, electrical design, and control programming move forward in separate phases. This creates one core problem: many issues are not found during design, they are found later. There are four common problems. First, issue discovery is delayed. Motion interference, abnormal cycle time, missing signals, and safety logic gaps often appear only after the equipment has been built. Second, collaboration is isolated. Mechanical, electrical, and controls teams work with different tools and data, so coordination becomes slow and repetitive. Third, validation depends on physical hardware. PLC and HMI programs usually cannot be fully verified until the equipment is assembled. Fourth, know-how, data records and experience is lost. Commissioning experience stays with individuals instead of becoming training, maintenance, and reuse assets. The traditional flow is design completion, equipment manufacturing, on-site commissioning, issue discovery, and rework. It is costly, slow, and risky. The core goal of VMC is to validate motion, cycle time, interference, abnormal scenarios, and control logic before the physical equipment is manufactured. VMC starts from the mechanical model. It defines motion, sensors, and actuators, connects PLC and HMI control logic, and turns the validation process into reusable digital twin assets. VMC has three defining strengths. First, single-source data collaboration. Commissioning is based on original mechanical design data, reducing the deviation caused by remodeling or model conversion. Second, direct designs for engineers, with capabilities for motion, sensors, actuators, and PLC/HMI signal mapping and commissioning. Third, commissioning becomes asset capture, models, signals, logic, cycle time, and abnormal scenarios can be reused for training, maintenance, and upgrades. The workflow can be divided into 5 steps. First, open the native CAD model in SolidWorks. Second, use VMC to define motion modes and sensors. Third, use VMC signal mapping so PLC control signals can drive the virtual model. Fourth, treat the virtual model like real equipment and validate motion, cycle time, interference, and other engineering conditions. Fifth, capture the validated model as a reusable twin asset. The key difference from the traditional workflow is this. Control validation no longer waits for problems to appear on site. It moves forward into the design stage. The VMC system structure connects mechanical data, signals, and control systems around the equipment model and within one commissioning workflow. On the input side, VMC supports native SolidWorks models, STEP, and other mainstream CAD data to obtain assembly and structural information. At the core, the VMC virtual commissioning engine provides 5 capabilities: motion definition for mechanisms, workpieces, and dynamic chains, signal mapping for sensors and actuators, simulation validation for motion, cycle time, and interference, and fault injection for abnormal scenarios and system robustness. On the output side, VMC connects PLC and HMI control logic, supports communication protocols such as OPC UA and Modbus TCP, and outputs commissioning models and twin assets. Specific interface support should be confirmed by project test results and software version. VMC provides 6 core capabilities. First, mechanism definition, motion groups, joints, follow relationships, and machine actions. Second, objects and sensors, workpieces, contacts, sensors, and actuators. Third, signal mapping, bidirectional mapping between PLC/HMI signals and virtual objects. Fourth, commissioning validation, validation of motion, cycle time, interference, and abnormal scenarios. Fifth, fault injection. Simulation of open circuits, actuator failures, and other fault scenarios. Sixth, asset reuse, continuous capture of models, logic, and commissioning know-how. The goal is not merely to make the model move. The goal is to validate the model with real control logic. The same virtual equipment in VMC can be used for control program simulation or connected to a real PLC. The first mode is software in the loop, or SAIL. VMC connects to a soft PLC or a control program simulator. This is suitable for control logic pre-commissioning, program validation, and parallel development by multiple engineers. The second mode is hardware in the loop, or HIL. VMC connects to real PLC and HMI hardware. This is suitable for real controller integration, I/O checks, and validation before on-site delivery. VMC has accumulated project test materials for TIA, Z-Develop, Siemens S7-1200, and other environments. The exact supported scope should be confirmed by version. VMC does more than validate normal motion. More importantly, it checks whether the system is safe, diagnosable, and recoverable when exceptions occur. Validation happens on 3 levels. First, normal scenario validation, motion sequence, cycle time, signal feedback, and control logic. Second, abnormal scenario injection, sensor faults, actuator failure, signal interruption, and similar conditions. Third, control strategy checks, alarms, interlocks, stop behavior, recovery, and safety logic. The goal is to turn on-site trial and error into repeatable validation during the design stage. Completing one commissioning project should not only solve one project. It should also leave reusable digital assets for future projects. These assets include 5 dimensions: the model, meaning mechanical structure and motion relationships, signals, meaning motion pair and PLC control signal mapping, logic, meaning PLC and HMI control programs, scenarios, including normal, abnormal, and boundary conditions, and know-how, including cycle time, parameters, and commissioning records. These assets can support module reuse, teaching and training, equipment maintenance, and solution upgrades. VMC can also connect with a modular mechatronics platform to form a full loop of commissioning, storage, retrieval, and reuse. Typical VMC applications cover 4 areas. First, industrial equipment development. Validate control logic before manufacturing and shorten the development cycle. Second, logistics systems. Virtually commission complex logistics equipment such as conveyors and sorting systems. Third, physical integration. Perform hardware-in-the-loop validation with real PLC and HMI environments. Fourth, education and training. Use commissioning experience and digital assets for talent development and skills transfer. Implementation can be organized in 4 steps. First, select a pilot, choose equipment or a unit with a clear structure and representative control logic. Second, build the model, define motion, workpieces, sensors, and signal mapping. Third, integrate and commission, connect the control program and validate motion, cycle time, and abnormal scenarios. Fourth, capture and reuse, create templates, courses, modules, and assets for future projects. The customer value is clear in 3 areas. First, risk moves upstream, issues are found before manufacturing. Second, collaboration becomes more efficient, mechanical, electrical, and controls engineers work around the same model. Third, know-how becomes reusable, commissioned assets can be retained, shared, and passed on. Let the equipment complete a credible virtual commissioning run before it is built. VMC Virtual Mechatronic Commissioning focuses on collaborative validation for complex mechatronic equipment and the capture of reusable digital twin assets.